Hello, I'm Tina Oelke and your instructor for PSYC155. Today we're going to take a look inside the brain. Chapter 2 gets very involved with a lot of technical information about biology. It can be overwhelming for those of us who like to deal with the softer sciences. Hang in there. I'll not only take you through a section of the chapters, but also show you the link between psychology and science. The very first thing that you might find handy to do is to print off the PowerPoints, which you can find on the resources page in the classroom. If you navigate to the resources page, you'll see under the chapter resources heading that there are two hyperlinks that say Chapter 2. One contains the full PowerPoints for this chapter, and one is an abbreviated PowerPoint version that is just for this audio lesson. We're not going to cover the entire biological perspective during our lesson today, just a section on the frontal lobes of the brain. If you click on the blue hyperlink that says Chapter 2 Audio, this will bring up the correct PowerPoint for today's lessons. Once it opens, you can then set your print options. I suggest setting it to the notes version. You can get there by clicking where it says Full Page Slides. Change that to 3 slides. It changes to a notes view. Then I would suggest printing in black and white, and if your computer can do it, I suggest changing your PowerPoint to two-sided. You might be puzzled as to why we have a chapter on biology in a psychology textbook. We sometimes take for granted the integrity and normal functioning of the nervous system. Only when there is damage through stroke, diseases like Alzheimer's, or brain traumas do we realize its importance. The affected individual and family are left dealing with adjusting to a new personality, life change, or resulting mental changes. This bridges the link between psychology and science. Having a better understanding of the foundation of science will help us in becoming better practitioners of psychology, be it in our everyday life as parents, children of adult parents, friends, or professions such as nurses, business owners, and teachers. Today we're going to be looking into the brain, specifically at the 4 lobes of the brain, the occipital, parietal, temporal, and frontal lobes of the brain. Then we'll finish up our lesson by discussing the association areas of the cortex, Broca's aphasia, where we'll meet someone named Sarah Scott, and Wernicke's aphasia, where we'll see an interview take place. The occipital lobe is a section of the brain located at the rear and bottom of the cerebral hemisphere. It contains the visual centers of the brain. It has the primary visual cortex in that it processes visual information from the eyes, like color recognition. It also is the visual association cortex in that it identifies and makes sense of the visual information. Because of the occipital lobe, we can read and then comprehend what we just read. The parietal lobe is located at the top and back of the cerebral hemisphere. It houses a center for touch, taste, and temperature through the somatosensory cortex, which is an area of neurons running down the front of the parietal lobes. It gets impulses from the skin like hot, cold, pain, and then processes that information. It also helps us judge distance, size, shape, know numbers and their relations, and manipulate objects. The temporal lobes are areas of the cortex that are right behind the temples that contain neurons responsible for the sense of hearing and meaningful speech. The primary auditory cortex processes auditory information from the ears, and then the auditory association cortex identifies and makes sense of that information. The temporal lobes help us not only to receive information, but interpret what we hear. Incidentally, it is thought that epilepsy in the temporal lobe triggered Van Gogh's creativity and his intense spiritual beliefs. The frontal lobe is located in the front and top of the brain. It is responsible for higher mental processes and decision-making, as well as the production of fluent speech. It helps guide our behaviors and inhibits inappropriate behaviors. The frontal lobe is what makes us human. This lobe also houses the motor cortex. It is a section of the lobe that is located at the back that is responsible for sending motor commands to the muscles of the somatic nervous system. The motor cortex, which is housed in the frontal lobe, and the somatosensory cortex, which is housed in the parietal lobe, run side by side, but both control voluntary muscles in the body. Maybe the athletes who are watching this might find this interesting. Studies of athletes who perform coordinated feats volunteered for brain scan. These scans showed that the motor cortex was activated when they observed movement in others and when they imagined themselves doing it too. Meet Phineas Gage. Phineas was one of the earliest cases of brain trauma that was documented. After having a severe injury, his personality changed dramatically. While working as a foreman for a railroad crew, he was struck through the head, specifically the frontal lobe, with an iron bar. Remember what the frontal lobe does? It guides our behavior and makes us human. It is documented that after his accident, Phineas's personality changed. He went from being a friendly, well-liked man to one who had a loss of inhibitions and one who had inappropriate behavior. Because of Phineas, we know that the frontal lobe houses personality. The association areas within each lobe of the cortex are responsible for the coordination and interpretation of information, as well as higher mental processing like learning, remembering, speaking, and thinking. Broca's aphasia is a condition resulting from damage to Broca's area, which is usually found in the left frontal lobe. This causes the affected person to be unable to speak fluently, to mispronounce words, and to speak haltingly. A famous study of a patient who likely had syphilis could only say one word, tan, led us to find out that speech is in the brain in a specific area. I'd like you next to meet Sarah Scott. Sarah is a young woman, probably your age or maybe even younger than you, who has Broca's aphasia. Through Sarah, we'll get a picture of what it's like to have Broca's aphasia. As you watch the video, I'd like for you to watch for the markers of this aphasia, which are unable to speak fluently, mispronounce words, or to speak haltingly.
Okay, so what's your name?
Scott. Oh, no. Sarah Scott.
That's right. And how old are you?
I can't.
Try.
I can't.
Oh. You're 19. 19.
Yeah.
Yeah. And what happened to you?
Stroke.
You had a stroke last year.
Yes.
And what happened? Can you remember what happened?
School and English class.
Okay.
And I book and I read it aloud, but I can't because stroke, and so I stand there, and also it's the same as the same of kind of thing as you know.
Pins and needles.
Yeah,
like pins
the
and
same, and also arm as well.
Leg.
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 Yeah.
And what happened after the stroke with your speech?
Well, I can't.
You have speech problems.
Yeah.
Do you know what that's called?
Yeah. Aphasia.
Yeah, good. I haven't heard you say the word before.
If you're interested in following up with Sarah's story, there are update videos on her on YouTube. Plug in a search of Sarah Scott with 2 T's and you'll be able to see her progress through the years into her early 20s. Her progress is remarkable. Now, Wernicke's aphasia is a condition resulting from damage to Wernicke's area, which is usually located in the left temporal lobe. It causes the affected person to be unable to understand or produce meaningful language. I'd like for you to listen in on an interview with a person afflicted with Wernicke's aphasia. As you are watching the video, please look for the markers of Wernicke's aphasia. Is the person able to understand speech? Is the person able to produce meaningful language?
I'm going to ask you some questions, and I just want you to answer yes or no. Okay? Yes or no. Is your name Smith?
What are they? What they're eating or vomit? I don't know. Right?
Is your name Brown?
Oh, Mr. Triangle, why isn't you walking those things this thing here for these?
Okay, just say yes or no. Okay, is your name Brown?
Well, it is here. Then let me see. I just don't know. No, I'm not going to eat any if I know.
No. Are the lights on in this room?
No. I just don't. Sorry what you're doing when you're just sitting walking around here.
You're doing fine. That's okay. I know it's kind of hard for you, but you're doing fine.
I can eat my own before and everything like that, and cleaning my bed is always clean me when I'm eating, and I can watch and everything in the morning.
I see.
I hope that this lesson on the lobes of the brain and the association areas gives you more insight and understanding of the behaviors and processes involved with our complex organ. That concludes what we'll be covering in our PowerPoint mini lesson. The reflective log assignment asks you to suggest ideas for future research designed to advance knowledge on the concepts in the chapter, and to apply the material learned in the chapter to a current news issue or to experiences in your own life. I suggest that you not only consider the concepts that you heard on this presentation, but also what you have learned in the rest of the chapter. Some interesting things to reflect upon would be a follow-up on Sarah Scott. What do you think about her progress? What do you think it would be like to have Broca's or Wernicke's aphasia, or to live with someone who has it? Or are you an athlete? What did you think about the motor cortex being activated, even if you just watched someone perform an action? The nervous system is so complicated. What did you think as you studied it? What further areas do you think should be researched? And what have you seen in the news recently that you'd like to comment on as it relates to Chapter 2? There are a lot of ideas out there from Chapter 2, and I hope that you have fun. And I can't wait to read your logs.